As we continue with quadrilaterals, today we're going to talk about parallelograms and how to prove a quadrilateral is a parallelogram. So there'll be a lot of definitions, a lot of characteristics that we'll be able to use and identify and work back and forth that if an item, parallelograms have certain characteristics, and then if certain characteristics exist, then we can determine that it is a parallelogram. So without further ado, a parallelogram is a quadrilateral with both pairs of opposite sides are parallel. So as we can see here in this image, AB is parallel to CD, BC is parallel to AD. And this is a parallelogram symbol. Very hard to use sometimes, so don't worry about it too much. So here in parallelogram ABCD, BC is parallel to AD, AB is parallel to DC. So we can see it too by the parallel marks. Other considerations. Okay, so parallelogram. Hopefully you can see here that this is a rectangle. It's intended to be a rectangle, and these are the things that we know. And a rectangle is a parallelogram. So I'm going to use it as our example. A parallelogram, then the opposite sides are congruent. Great. Opposite sides of the parallelogram are congruent, which would be very reminiscent of a rectangle for us in the past. Then parallelogram, then the opposite angles are congruent. Sure enough, if I label this A, B, C, D, I can see that angle A is congruent to angle C. This is sort of, you could say, hey, they're all congruent, but the opposites are congruent, and that's what's important. Angle B is congruent to angle D. Here, looking over here, just looking at this, I could say that it appears that angle A is congruent to angle C, and angle D is congruent to angle B, and that would be opposite angles are congruent. And then let's see here, consecutive angles. Consecutive angles are supplementary. So what they're saying is consecutive angles, angle A plus angle B, are supplementary, so they equal 180 degrees. Angle B plus angle C equal 180 degrees. That's it. And if I look over here on this rectangle example, sure enough, 90 plus 90 is 180 degrees, or consecutive, B plus C is 180 degrees. So that's what they're getting at. That's a known characteristic. And then if a parallelogram has one right angle, then all four, then it has four right angles. So we don't have to have all of these labeled, because by the definitions that we just encountered, they told me that opposite angles are congruent. So if this is 90, then the opposite angle would be 90. Okay, that's what was one of the definitions. And then they said that consecutive angles are supplementary. Well, angle C plus angle D are supplementary, then that would be 180 degrees. So if angle C is 90, then guess what? Angle D is also 90, and then we have that opposite angle thing. So those are just theorems, things that we can prove. So using that information, use the properties of parallelograms to find the value of CD. CD. Okay, goodness. CD. What is the value there? Well, opposites, right? This is congruent to that, so therefore CD is going to be 4 feet. That's what they're looking at. AC would be 1.5. They didn't ask us for it, but it's the opposite. Angle-wise, I could do the angles too, and again, it's not asking me that, but if angle C is 45, I know angle B is 45. I know that these two should add up to 180 degrees because they're consecutive, so this is 180 minus 45, which is 135 degrees, and then this is opposite, which would be 135 degrees. So those characteristics, those definitions. So here, again, find the measure of angle D. If this is 106, the opposite is 106. So using those definitions, FG, this is congruent to this. So DE is 8 inches, therefore FG is also 8 inches. So again, using my characteristics. Now, proofs. We aren't going to do proofs, it's not required. But let's think. They want to prove that HJ is congruent to ML. And it tells me that given that HJKP is a parallelogram and PKLM is a parallelogram. Okay, so just understanding what does that mean and using that information. If they're parallelograms, I know that opposite sides are congruent. And now, if I focus on the PKML, opposite sides are congruent. If these two are congruent. Now, if I look, I can turn around and say, well, according to the properties of parallelograms, then it looks like HJ is the same length as ML. I don't know what that length is, but according to my tick marks, they're congruent based on those properties. This, of course, is not necessarily congruent to anything other than those two. We don't know for sure. But yeah, definitely HJ is congruent to ML based on those definitions. Let's see here. Now again, they have a parallelogram, and they told us that this is congruent to this. And they want to prove that angle J is congruent to, they want us to prove that this angle is the same as this angle. Okay, so with that, let's see. What do we know? We know that if this is a parallelogram, that KL should be the same measurement as JM, but we're looking for angle measurements. So parallelogram, I know that this angle should be congruent to this angle. So far, so good. I know, what else do I know? I know that this angle should be congruent to this angle. What else do I know? I don't even need to know that. That wasn't necessary. Let's just look at this from a isosceles triangle perspective. If both legs are congruent, then they told me that both base angles are congruent. So the two base angles are congruent. So there you go. If this is congruent to this, then if you look, this is also congruent to that. So there you go. We were able to prove those two are congruent, and I think that's what they asked us to do. Or they asked us to prove that was congruent to that. So there you go. We were able to do that using the base angles of isosceles triangle. Diagonals, here is, this one is 7.7, right? Theorem, we can prove it. It just tells us that diagonals bisect each other. So when we draw the diagonals in, they will bisect each other. So this piece will be congruent to this piece, which will be congruent to this piece, which will be congruent. Oops, sorry. They bisect each other. So these two pieces are congruent. These two pieces are congruent. And based on what kind of parallelogram it is, they may all be congruent, but that's not necessarily what we're getting to here. And then it says, if a quadrilateral is a parallelogram, each diagonal separates the parallelogram into two congruent triangles. And that is saying that if this diagonal, I have two congruent triangles. I know that this is congruent to this is congruent to this, and this is congruent to itself. So technically you do create two congruent triangles. Many ways to come up with it, but this indicates right here just side, side, side. Okay. So here the diagonals do bisect each other. So as we talk about, find the values of x and z in this parallelogram, which means that this is congruent to this, because those are my diagonals being bisected. We know that E is the midpoint, so you can make those two things equal to each other. Let's see here. I know here, I'll just say that if we go to part B, that this segment is congruent to this segment. And they made them equal to each other. And then did solve for the variable of z and came to 4.5. Now, the other one, it is telling us that ADC is 4x. So ADC, this entire angle right here is 4x degrees. And DAB, this entire angle is 2x minus 6. And what we know about the two consecutive angles are that they equal 180 degrees. So they did we can do the substitution to solve one, the other, combine like terms, bring down my -6, add 6 to both sides. 186 is equal to 6x, divide by 6, and then we find out that x is equal to 31. Okay, so there's a couple extra steps in here they didn't give us. So just keep that in mind using those characteristics. Parallelograms in the coordinate geometry. Okay, there's a lot of words and a lot of effort going into this problem. Thomas is making envelopes to sell with homemade cards. He uses different style of paper to create the flap of the envelope, and he edges the envelopes with washi tape. The envelopes are parallelograms, and the edges of the flaps lie along the diagonals of the parallelograms. Find the area of the flap and the perimeter of the envelope. Okay, the area of the flap, so this is my flap we're talking about. You may not see it on your paper, or it may be difficult to do purple. And in order to find the area of that, it looks like a triangle. The area is going to be, as we've done before, 1/2 base times height. I could simply look at this and say, hey, my base appears to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So the area should be equal to 1/2 base times my height. 1, 2, 3, 4, 5. So I was able to count that on the coordinate plane. We could use some distance formula, but not necessary right now. So we end up, the area is going to be, I think that comes to 35. So the area of the flap is 35. Now it says we did find the height. They did the midpoint, but we're okay. I think what we did is quite suitable and easy to figure out. So here, we could use the distance formula again, but I am just going to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my width is possibly 10, and then my length is, we already determined that was 14. So my length is 14. Now perimeter, of course, I have to do 2 times my width, and then 2 times my length to find out the then we turn around the height difference. Okay, they came up with that. They determined, yes, that the area of the flap was 35 centimeters. Now, the length of the washi tape needed to create the border. The length of the washi tape perimeter. And in doing so, perimeter equals 2 times L plus 2 times W, and they came up with 48. That's it. That's what we're doing here to using these properties of parallelograms. And then here in this check, Jamina is making a quilt. And each block is a parallelogram made of a single piece of patterned fabric and is trimmed with a gray border. Okay. Find the area of the fabric used to make the block. So we want to find the area used to make this block. And then find the length of fabric used to make the border of the block. So we want to find the area of it and then the border, okay? And then round to the nearest tenth. So I have a feeling we could be using the distance formula to find out what this is and to find out what this is. So when we do the distance formula, we find out that the length of one side is going to be the square root of 18. You might be able to simplify that and call that the 3 times the square root of 2, and we'll do some more of that later on in this unit, but that was simplifying radicals is one of your algebra skills that hopefully is not lacking. So here, we know if the length of one side is 3 square root of 2, in order to find the perimeter, we would simply, the perimeter in this case is going to be 2 times 3 square root of 2 plus 2 times 3 square root of 2. So if you did the distance formula, this was, this was what I did, distance formula here, but if we turn around and did it again, we would find out that this distance is the same. Okay, so with that, we have that, so this turns out to be the perimeter is going to be 12 square root of 2. That's the, and I know we can put that in the calculator and come up with a decimal. I just, don't have it with me right now. So that would be 12 square root of 2. And then if I wanted to find the area, length times width equals my area. So I would have 3 square root of 2 times 3 square root of 2, which is going to be 9 square root of 4, which is the same thing as 9 times 2, or 18. There we go, 18. And that is using those properties, coordinate plane, distance formula, etc. So let's see here. Looking at the next example, this unit we're talking about tests. And this is simply, using our theorems that, if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. We're using that information. If both pairs of opposite angles of the quadrilateral are congruent, then it's a parallelogram. If the diagonals of a quadrilateral bisect each other, then it's a parallelogram. And then if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. That one's really the only one that isn't straight off our definitions, is this final one. But yeah, if we have one set of opposite sides that is parallel and congruent, then we have a parallelogram. So identifying, in this case, if I look at this, opposite sides are congruent. So I believe we have a parallelogram if opposite sides are congruent. So using 7, 9 there. And then here, what would, in order for this to be a parallelogram, we know that the opposite angles have to be congruent. So in order for this to be a parallelogram, what does y have to equal? What does x have to equal? So let's see here. The top of the eraser appears to be a parallelogram. Find the values of x and y so that the side of the eraser is a parallelogram. Okay, parallelogram. This equals this. That will solve for x. So remember, opposite sides are congruent, or opposite angles are congruent. So I have 7x is equal to 56. Divide both sides by 7. And x is going to be equal to 8. So there's 8, I know that. And then the same thing applies for the other opposite angles. That 5y minus 26 is equal to 4y plus 4. Do your inverse operations, right? Subtract 4y from both sides. Then I have y minus 26 is equal to 4. I'm going to add 26 to both sides. And then y is going to be equal to 30. So there you have it, my x and my y. If the value of x is 8 and the value of y is 30, then it is a parallelogram. If the values were anything other than those two numbers, it would not be a parallelogram. So that's what they're saying. The condition that allows it to be a parallelogram is x equals 8, y equals 30. Looking here more, let me drop this study tip here real quick. A quadrilateral needs to pass only one of the 5 tests to be proven a parallelogram. all of the properties of the parallelogram do not need to be proven. If you've proven one, you can keep going because that's all you needed to do to keep working. Okay, check. It says the mosaic pattern of the floor is made up of different tiles. Find the values of x and y so that the tile is a parallelogram. Again, if it's a parallelogram, we want this to equal this. We want this to equal this. And that's how we can solve for both x and y. And there you go. When we solve, it turns out that I made these two sides equal to each other. I did my inverse operations, right? I subtracted 2y from both sides to get my variables together. That became 0. I went ahead and added 9 to both sides to move my numbers away from my variables, and I have 2y is equal to 14, dividing by 2, and y is 7. Did the same thing over here and inverse operations and came up with x equals 3. And then it says select the theorem you use to find the values of x and y. Well, I have opposite sides are congruent. Both pairs of opposite sides are congruent. Both pairs of opposite angles are congruent. I didn't touch angles. If a diagonal bisect each other, I had nothing to do with diagonals. And then if one pair of opposite sides is congruent and parallel, those are accurate statements, but I didn't do anything with angles or parallel. So what I dealt with was, number one, I proved that the opposite sides were congruent. And I will just say to identify parallelograms on the coordinate plane, if you do the midpoint, they should bisect each other. So the midpoint of my two diagonals should bisect each other. If they do, then you have a quadrilateral. Now, for this one, looking on this graph, I could eliminate it as being a quadrilateral because I can see that this side is 5, this side is 4. My opposite sides are not congruent, so therefore I know that that is not a quadrilateral. This one, coming down here, I will just say that we're going to use the midpoint formula to show that they bisect each other, because if they bisect each other, the midpoint should be the same values. So here, looking at this, determine if it's a quadrilateral. And I was able to do the midpoint for AC and found out that the midpoint was 9/2 and 1. And then when I did the midpoint for BD, I found out that the midpoint was 9/2 and 1. Therefore, they intersect at the same location, so they bisect each other. So we know that it is therefore a quadrilateral. And that's it. And we're going to go ahead and work with this. Just understand that proving is often just using our definitions to find the values that will make things right. And let's move on with our work.